In this video, we're going to talk about set theory, which is covered in Chapter 2 of our Math 120 textbook. A set is a collection of objects whose contents can be clearly determined. And objects in a set are called the elements or members of the set. A set must be well defined. This means that the contents can be clearly determined. When I'm writing a set, I could write a set in words, like the integers between 1 and 5. If I'm saying the integers between 1 and 5, I need to know that integers means just those whole numbers, no fractions, no decimals. If I want the numbers in between 1 and 5, that does not actually include 1 and 5. So those would be the numbers 2, 3, and 4. If I'm writing this as a set, I put the squiggly brackets around it to say this is what's in that group or what's in that set. So both of these things, the words and this group of numbers in the brackets, are both the set. The elements are the numbers 2, 3, and 4. They are what is included in that set. And when we say a set must be well defined, it means that when I describe it and you describe it, we have to describe the same things. So if I just said something like the set of good movies, that is not well defined. Because what I think is a good movie, you might not think is a good movie. But if I say something like the set of all movies that have won an Oscar, it's well defined. We can clearly look up what movies have won Oscars and what movies have not. Most of the times when we try to visualize sets, we use Venn diagrams. With a Venn diagram, we start with a big rectangle that has that letter U inside of it. That U represents the universal set, and it is a set that contains all of the elements being considered in a certain discussion or problem. Then we'll have some sort of defined set, set A, where we put everything in a circle. When we're thinking of the different representations of sets, there's 4 ways they can be represented. The first way are completely disjoint sets, where set A and B have absolutely no overlap, nothing in common. So where we could say, set A is the set of people with dogs, who own dogs. And set B is the people who do not have any dogs, who are without dogs. Right? There's absolutely no overlap. There's no way to have a dog and not have a dog at the same time. It's also possible to have proper subsets. So where A and B are both sets, and A is a part of B. It's completely inside there. So if we said something like set B is the people who own dogs. And we say that set A is the people who own a specific kind of dog. So let's say a lab. Then it's a proper subset, right? Everybody in set A still fits in set B. They own a dog, but it's a smaller group. Because all of these people outside here would still have dogs, but would have other breeds, like retrievers or poodles or mutts. They would all be out there, but still in set B. It's also possible to have equal sets, which is usually where we just describe the same set in different ways, but sometimes they are the exact same thing. So we could say something like set A is all of the people who own dogs. And we could say set B is all of the people who own canines. write a different name for the same thing. The kind of Venn diagrams that we're going to see most often are ones like these, where the sets have some common elements. So that could be something like, if we stay on that same thing, A is people who own dogs, and set B could be people who own cats. So if I owned only a dog, I'd be over here. If I owned only a cat, I'd be over here. But if I had both a dog and a cat, I would be in that overlap. And more often than not, that's what happens when we take a survey.